In this video, I will explain how you can handle errors in your Node and Express.js project, ensuring your app stays stable and user-friendly. We'll cover how to create a custom error handler as well as how to throw custom errors. Hi, my name is Alex. I'm a senior software engineer with years of experience in API development. My goal is to help you become a more skilled and proficient developer. Let's get started. I am in the Node and Express.js project. Let's take a look how error handling works in Express. As usual, the link to the GitHub repo with the code will be in the description. Let's go ahead and open src folder. Go to v1 routes tasks folder, and in the controller.ts file we defined two functions, list tasks and get task. Let's go ahead and throw an error in the get tasks function. We will start the server and open API test.http file to make a request to get task by ID endpoint. We can see that we got an error response. It's not a pretty response, but it will do. It says error oops, we got an error stack, and we can also see that error is logged to the console. So API didn't break, although we didn't handle the error we threw. If we are going to try again, we're going to get the same response. So API is working just fine. Express has a default error handler that tries to catch all the errors and then returns the response and logs out the error stack. Now let's go back to the controller and change the function getTask to be an async function. Let's hit the endpoint getTask by ID again, and now we can see we didn't get any response. Express failed to handle this error and crashed. Express version 4 does not handle errors in the async route handler functions. From my experience, I can tell that route handler functions will be mostly likely async because you will be either making a request to the database or some other APIs to get data and return it to the user. To handle the error in Express 4 in the async route handler function, you need to use try-catch. Let's go ahead and use try-catch. We're going to try, catch the error, and pass it to the Express error handler using next function. Move the code inside the try block, and we need to add next function as a parameter and import its type from Express. Now let's go ahead and repeat the call again to get task by ID. The app doesn't break. It returns the error response as before and logs the error stack to the console. As you can imagine, it's easy to forget to use try-catch in route handler functions everywhere in your project. Fortunately, Express 5 is out and it added support for returned rejected promises from errors raised in middleware. Basically, what it means is that we don't need to use try-catch in route handler functions anymore in Express 5. If you would like to learn more about Express 5 release and new Express features, please check out my video on this topic. Let's go ahead and upgrade to Express 5. In the package.json file, we can see that Express package we have installed is version 4. Currently, Express tag latest is still version 4. So in order to install version 5, we need to use next tag. Let's go ahead and do npm install express at next. Now, as you can see, we have Express 5. And also you need to check that the types for Express are also at version 5. I have them at 5. Unlike with Express, the latest tag for Express type is 5, not 4. If your Express types for some reason don't have version 4, all you have to do is to use the following npm install at types / express at latest. This will upgrade Express types to version 5. Now let's go ahead and remove try-catch block that we put in place before, save the changes and start the dev server with npm run dev. We'll go to API test.http file and try the request again. As you can see, we're getting a response, so the server doesn't crash anymore even if we don't use try-catch. Default error handler in Express does a pretty good job at responding with error and logging it out, but in most cases you would want to use your own custom error handler first before Express's default error handler kicks in order to return a custom response to a user and not just the error stack. So let's go ahead and create a custom error handler. Let's create errorhandler.cs file in src middleware folders. We're going to put the following code in there. We're going to import next function request response from express to type the function parameters for TypeScript config that contains configuration settings like a debug mode. We will add debug property to the config shortly. Get error message, a utility function that extracts an error message from an error. In Node.js, any type can be thrown and you can expect to use .message to access error message. We will also create get error message function in a minute. We export default error handler function that has the following parameters. Error of type unknown for the reasons we mentioned earlier. Rec next represent the request, response, and next middleware functions respectively. You may notice that unlike crowd handler function, error handler function has error as the first parameter. Error handler function has the following logic. If the response headers have already been sent, res.headers sent, or the application is in debug mode, config.debug, the error is passed to the default error handler using next error. Default error handler does a good job of logging errors, so we can use it if we can't send a response since it is already been sent or we want to log the error. Otherwise, it responds with a 500 status code and a JSON object containing an error message. The message is either retrieved using a get error message function or defaults to a generic default error message. Basically, the goal of the error handler function is to handle server-side errors and ensure proper logging and response to the client. Now let's go ahead and define get error message function. Let's open the utils file and put the following code in there. This code defines a function called getErrorMessage that takes an error parameter of type unknown and returns a string. It handles different types of errors and extracts the error message. If the error is an instance of the error class, it returns the message property. If the error is an object with a message property, it converts and returns that message as a string. If the error is a string, it returns that string directly. If none of the above conditions are met, it returns a default message an error occurred. This utility function is useful for safely extracting error messages from various types of errors that might be thrown in a JavaScript or TypeScript application. Next, we will update the config.cs file to include a new debug property. This property will be based on the appdebug environment variable. We will set it up so that if appdebug is set to true, our debug mode will be activated. If appdebug is either false or not set at all, debug mode will be off. The final step is to add the error handler in the server.ts file. But before we do that, if you're learning something new from this video, please like and subscribe to our channel to help YouTube recommend it to more viewers. First, we need to import the error handler. Then we'll correct a typo by renaming Middleware folder to Middleware. After saving these changes, we'll add the error handler as the last middleware in our create server function. To do this, we'll use error handler at the bottom of the server.ts file. This ensures that the error handler will be the last middleware to process requests. Once we made these changes, we'll start the server with npm run dev. We can then test our implementation by sending a request to get a task by ID using the API test.http file. As we can see, our custom error handler successfully captures the error, extracts the message, and sends it back to the user. However, during development, we might want more detailed error information. Let's configure this by setting up the appdebug env variable. We'll add appdebug equals true to both our .env and .env example files. After saving these changes and restarting the server, let's make a request to the getTaskById endpoint. We receive a response containing the error stack trace. This occurs because the appdebug logic is active. Checking the appdebug environment variable and passing the error to default handler, which then returns the detailed stack trace for debugging purposes. In addition to a custom error handler, it's beneficial to create custom errors for better flow control in our application. This approach can enhance our error handling strategy. For instance, in our test controller, we have an opportunity to implement a more specific error. Instead of a generic error, we could use a custom entity not found error. This would be particularly useful in scenarios where we are trying to retrieve a task that doesn't exist for a given ID. Let's go ahead and create custom error.ts file in the src errors folders, and we'll put the following code. This code defines a custom error class called custom error that extends the built-in JavaScript error class. Custom error will be a parent class for all other errors to extend from. Here's a breakdown of the structure and functionality. The class uses a generic type C that extends string. This allows for custom error codes to be passed when creating an instance of the error. It has three properties: message, a string describing the error; status code, a number representing the HTTP status code, for example 404 for not found or 422 for unprocessable request; code, an optional property of type C for a custom error code. The constructor takes an object with the three properties: message, required string; status code, required number; and code optional of type C. In the constructor, it calls super to properly initialize the base error class, and it assigns the passed values to the corresponding class properties. The custom error class allows for creating more specific and informative error objects in your application, which can be especially useful for API responses or internal error handling. Now let's go ahead and create entity not found error class. We will create it in src errors folders as well. Since we're using custom error as a parent class, the code for entity not found error class is quite simple. We import the custom error class from the file we just created. The entity not found error class extends custom error with a generic type parameter error code. We will define error code type in a minute. The class body is empty, which means it inherits all properties and methods from custom error without adding any new ones. So let's go ahead and define the error code type. We are going to create type definitions file types.d.ts in the same src errors folder. We will add the following code. This code defines a TypeScript type called error code. It uses a union type to specify two possible string literal values. Error and F stands for not found error. Error valid stands for validation error. This type definition allows you to use these specific error codes in your application, ensuring type safety when working with error handling. Next, let's update the error handler middleware to add our custom error. We'll modify the code to check if the error is an instance of our custom error class. To do this, we first need to import the custom error class into our middleware file. Next, we'll add logic to check if the error is an instance of our custom error class. If it is, we'll respond with a JSON response containing the error message and an appropriate status code, which could be 404 or 422 or something else. This approach allows us to handle our custom errors more precisely, providing more informative responses to the client. Now let's update the tasks controller. Instead of using a generic error, we'll throw the entity not found error. We'll start by importing this custom error class. When creating an instance of entity not found error, we'll provide an object with the following properties: message entity not found, or you can also put task not found; status code 404 indicating a not found error, and code err and f. Let's test our custom error implementation. After running npm run dev, we encounter a TypeScript error. This indicates that our types definition file in errors folder isn't being recognized by TS node. To resolve this issue, we need to make an adjustment to our tsconfig.json file. We add TS node files true to our tsconfig.json. After saving these changes and restarting the server, our setup should be functioning correctly. The API is now running on port 3000. Let's test it using the API test.http file. When we send a request to the getTaskById endpoint, we notice that we are still receiving the full error stack trace. This indicates that our debug mode is still active. Let's update our environment variable. In the .env file, we'll change upDebug to false. After saving this change and restarting the server, let's try the request again. This time we receive our custom error message, entity not found, along with the error code ER and F. This is how you can implement custom error handling and custom errors in your Express.js application. By following these practices, you can significantly improve your app's stability, provide more meaningful feedback to users, and make debugging easier. Finally, don't forget to check out the next video in Node Express.js series to level up your Node and Express.js skills.